right, we are now in Unit 3, so go ahead and find your new Unit 3 notebook, type your name on slide 1, and then let's get started. What are some vocabulary words we need to know to represent a function? So first we have element. What's an element? It is a member of a set of different elements. For example, if I asked for a list of everyone in the class, and I got a list of all the names, then you could say that list is the set. It's the set of everyone in the class, and each person's name would be an element. So, Mark is an element in that set of names. What is a relation? A relation is a set of X and Y values, usually represented in ordered pairs. So a set of X and Y values usually represented in ordered pairs. What's a function? A function is a relation in which each X value is paired with exactly one Y value. So what does that mean? So essentially a relation is any set of points. There's an X and a Y value going together, and as long as it's just a list of X and Y values that correspond with each other, it's a relation. A function is a subset of that group. So in order to be a function, it does have to be a relation, but specifically, it's only a function if each X value is paired with exactly one Y value. So what are some ways we can describe functions? There's 4 main ways we're going to do in this class. So first, verbally, which is a description in words. For example, we're going to do all of these based off of this equation here. So in words, I could say the output is twice the input plus 1. So the output, my Y value, is twice the input, or X, plus 1. That's verbally. Algebraically is an equation, like the one I've given you. This is algebraic. Numerically, we can provide a table of values. So let's come up with a table of values here. So I've been given an equation, so I can really pick my inputs. I can make X whatever I want. Typically, if you're given an equation and asked to make a table, we usually want some positive and some negative. So I'm going to do -2 and -1 and 0 and 1 and 2. So again, some positive, some negative, and also 0. So let's see what happens if I put in those values. Putting in a -2, 2 times -2 plus 1. So 2 times a -2 would be -4, plus 1 would be 3. So my Y value is 3, and just hit space a bunch to get the 3 in the Y value. -1, if I put in a -1 here, 2 times -1 is -2. -2 plus 1 is a -1. Next, I have 0. 2 times 0 is 0. 0 plus 1 is 1. If I put in a 1, 2 times 1 is 2. 2 plus 1 is 3. And then last, if I put in a 2 as my input, 2 times 2 is 4, plus 1 is 5. So there's my table. We can also do visually or graphically, which can be a graph or a diagram or a mapping diagram. So let's start with the mapping diagram. So in a mapping diagram, you put all your inputs, your x values into one circle, and all your y values, your outputs, into the second circle. Really important, you cannot repeat a number in a mapping diagram. You only use a number once. So I'm going to type in the numbers. I have these little dots here. That's kind of just to space it out. You can delete them or leave them. So we got -2, -1, 0, 1, and 2. So those are all my inputs. Again, notice none of them are the same. If this was a -1 again, I wouldn't type it twice, just once. And then my outputs. So I'm going to type in my output values. Just to show you, I'm going to actually mix up the order a little bit. So I'm going to put a -3 here, and then a 1, and a -1, and a 3, and a 5. So they're not necessarily in order. So I have my x's and I have my y's. Now I need to show the relation with arrows. So we have these arrows off to the side. We're going to use the one-sided arrows here. And I'm going to show that if your input is a -2, your output is a, oh, whoops, that should have been a -3. So -3. So that one's good. Then next, I have -1 is -1. So I'm going to take this arrow and I'm going to show that it goes from -1 to a -1. So I'm going to grab that dot and put it down here. All right, the next one is 0, 1. So I'll grab another arrow, and that one needs to go from 0 up to 1. 1 goes to 3, so if your input is 1, your output is a 3. And if your input is a 2, your output is a 5. So there you go. And real important, they have to be arrows. If you were drawing this by hand, have to have an arrow on the output side, because that's showing you start with your input and then you get an output. And then we have a graph. So let's think about what this graph looks like. I have a whole list of points. Because this is an equation, I could put in any number I wanted for x. I could put in decimals or fractions. So I'm going to drag this a little bit. Let's see. 0, 1, so it's got to go through 0, 1. So I can put that on 0, 1 for now. And what's the next point? 1, 3, 2, 5. So if I put that on over 2 is x. 1, 2, 3, 4, 5 is up here. And then I can kind of drag this down to get the rest of it. So the most negative point we did was -2 and then -3. So that's where your line is going to be. And again, it continues in both directions forever. So how do I tell if something is or is not a function? So what is a function? We kind of talked about this on the last slide, but it means that each element in the domain, which is your x, is paired with exactly one element in the range, which is your y values. In other words, each input or x has exactly one output, which is your y. So for every x value, there must be only one y value. To test if a relation is a function, if you have ordered pairs or a table or just a list of points, if your x values repeat and have different y values, then it is not a function. So if your x values repeat and they have different y values, it's not going to be a function. So for example, if you have the point 2, 3, and then you also have the point 2, 7, I have the same x value twice, but it has a different y value, so that would not be a function. What if you're given a graph? If you have a graph and you need to tell if it is a function or not, you will use the vertical line test, sometimes abbreviated as VLT. How do we use the vertical line test? That tells us that if a vertical line intersects the graph more than once, then it is not a function. So if you imagine, for example, a circle, if you graphed a circle and drew a vertical line through it, it would hit 2 points. So that would not be a function. All right, let's take a look at some examples and determine if they are functions or not. All right, for this first table, I want to look at all the x values, -5, -3, 0, 1, and 2. Are any of those the same? No. So that means I have no issues with x repeating and giving me a different y value. So this is a function because x values don't repeat. How about this next one? 3, -1, 0, 2, 3. Oh, I have 3 twice. 3, 5, and 3, 3. So those 2 points, which I'm going to circle here with those circles off to the side, have the same x value but different y values. So this is not a function because the same input of 3 has 2 different outputs. All right, next slide. Another list of points. Okay, again, you want to look at your x values. -5, 3, 0, -1. Well, none of those were the same, so we are good. This one is a function because x does not repeat. Next one, -2, 0, 2, 3, 2. Oh, I have 2 twice. 2, -4, and 2, +4. Almost the same, but not quite. -4 and +4. So this one is not a function. Again, your x repeats. It has different outputs. All right, now we have a mapping diagram. Now you have to be a little bit more careful with the mapping diagram because they use arrows. So again, they never repeat. So what you're looking for is an x value that gets used twice. So if I look at this -4, there's 1 arrow coming out of it. So there is a point -4, 4. But look at this -1, there's 2 arrows coming out of it, which means there's a point -1, 0 and -1, 7, which means that that output or that input has 2 different outputs. So this is not a function. And we can say that the x value of -1 repeats. How about over here? -3 has 1 arrow, -1 has 1 arrow, 2 has 1 arrow, and 4 has 1 arrow. Now this doesn't matter. Why? I can use as many times as I want. In fact, they could all go to 4 and it would still be a function. It's x that cannot repeat. So this one is a function. And then no x values repeat. Not having the best luck typing. Okay, then we have these graphs. So with a graph, you use that vertical line test. If you can draw a vertical line that hits more than 1 point, it is not a function. So let's look at these points. If I drag this blue line over here, well, here I only hit 1 point. Here I'm hitting none. I'm hitting 1 point. Up, but look here. There's 2 dots right on top of each other. So that means they have the same x value because you're going over 1 and then up 0. So that's 1, 0, and then 1, 3. So it does not pass. So sorry, it's not a function. And it does not pass the vertical line test. How about this next one? Well, there's a point here. That's the only one on that vertical line. There's one here, one here, one here. There's nowhere I draw a line where I can hit more than 1 point. So this one is a function. because it passes the vertical line test. All right, over here, can I draw a vertical line that hits more than 1 point? Yep, right there, I'm hitting 2 points. So again, not a function, does not pass the vertical line test. Last one, can I find a location where if I draw a vertical line, I hit more than 1 point? Looks like no, everywhere is good, so that last one is a function and it passes the vertical line test.